Hi, my name is Rhiannon and I'm a pharmacologist. I'll be talking to you today about some of the science surrounding SNRIs and specifically our new drug venlafaxine. Crystal has already mentioned that SNRIs are a type of drug used primarily to treat depression and anxiety, and my aim is to help you understand exactly how that occurs physiologically. As Crystal mentioned, there are 6 SNRIs in existence and currently there are 3 approved for use by the Therapeutic Goods Association in Australia specifically. These are venlafaxine, desvenlafaxine and duloxetine. SNRI stands for serotonin norepinephrine reuptake inhibitor. As the name suggests, drugs of this type act by inhibiting the reuptake of serotonin and norepinephrine. I'll go into this in detail in just a moment. First, though, it's important to be familiar with these compounds, so I'm going to cover some of the biology basics. Serotonin is a monoamine neurotransmitter, a chemical messenger which transmits signals across nerve endings in the body. It has the chemical name 5-hydroxytryptamine, or is sometimes referred to as 5-HT for short. The normal biological function of serotonin is complex, but some of its psychological impacts relate to mood, cognition, reward, learning, appetite, and memory. And it also plays a role physiologically in processes such as vomiting and vasoconstriction, the tightening of blood vessels. Norepinephrine is also referred to as noradrenaline, or chemically as 4,1R2-amino-1-hydroxyethylbenzene 1,2-diol. As with serotonin, norepinephrine is also a naturally occurring chemical in the body, but it acts as both a hormone produced by the adrenal glands and a neurotransmitter. The purpose of norepinephrine is principally to prime the body and the brain for action. Levels of norepinephrine peak during times of stress and danger. It's responsible for what we know as the fight or flight response. It's also responsible for increasing arousal, focus, alertness, enhancing memory formation and retrieval. And in the body, norepinephrine plays a role in increasing heart rate and blood pressure, releasing stores of glucose for energy, and redirecting blood flow away from the GI system toward muscle. Anxiety and depression are thought to be caused by reduced levels of both serotonin and norepinephrine in the synaptic cleft, and SNRIs restore their levels by binding to their reuptake transporters, which prevents the reuptake and the subsequent degradation of each compound. The transporter proteins responsible for the reuptake of serotonin and norepinephrine from the synaptic cleft back to the presynaptic nerve terminal are the human serotonin transporter, SERT, and the norepinephrine transporter, NET. Most SNRIs are significantly more selective for serotonin than norepinephrine, but the inhibition of both serotonin and norepinephrine together has been shown to offer advantages over other antidepressant drugs by treating a wider range of symptoms. Our preliminary research has found that venlafaxine is a more superior SNRI than any others currently on the market. This can be best seen by comparing the pharmacodynamics for each drug. Ki is the inhibitor constant, which represents how potent an inhibitor is, and the IC50 is the half maximal inhibitory concentration, which represents the effectiveness of the inhibiting substance. In essence, a greater IC50 is reflective of a greater strength of the inhibitor as a drug, and a smaller Ki means a greater binding affinity and a smaller amount of the medication is needed. The suggested dosage for venlafaxine is 50 milligrams, which is only a third compared to venlafaxine, 150 milligrams, yielding the same clinical results to treat anxiety and depression, but mitigating the majority of side effects that are experienced with other SNRIs, such as headaches, nausea, and abrupt discontinuation syndrome. With a single daily dose, the half-life of venlafaxine is 12 hours, and steady-state concentration is achieved during day 2. This is significantly better than desvenlafaxine and duloxetine, which can take up to 5 days to reach steady-state levels. This is an exciting time in drug development. Lanlafaxine has the potential to change lives. I hope that you've learned something new, and as I do, you see the potential for our new drug. Thank you for your attention today. In a moment, you'll be hearing from our development team about what's next.